Welcome back. Today we're going to be moving into Unit 10 in Statistics, and we're going to be talking specifically about scatter plots. Let's get started. So let's take a look at some information about scatter plots. First of all, scatter plots show a correlation, and that data in the scatter plot must be quantitative, and this means that the data values must be numbers. Remember, there's two types of data. There's qualitative and quantitative talks about numbers, and that's what we're going to be looking at when we're talking about scatter plots. Each point represents one observation, so one thing that happened, and scatter plots help us see patterns and make predictions based on those patterns. So now let's take a look at a basic scatter plot. So let's take a look at Elmer's scatter plot. It says Elmer surveyed his neighbors about their households and showed the results in the scatter plot to the right. I want to answer some basic information about the scatter plot before going ahead and answering more in-depth information about the scatter plot. So it says in this scatter plot we are comparing what? We got two things that we're comparing, and those things are listed on the axis of the scatter plot. And in this case we're talking about the number of pets compared to the number of people. So the number of pets and the number of the people are the two things that we're comparing. Then it asks how many households were in this survey. And the easiest way to figure out the number of things that were in a survey is we're going to count the dots that are on our scatter plot. Now sometimes scatter plots have way too many dots, and that's not the case in this one. We're going to count the scatter plots, and that will tell us the number of households in the survey because that's the number of observations. So if I count up all my blue dots, I end up with 12. So there are 12 households in this survey. Now let's go ahead and take a look at the survey and answer a little more complicated questions. Alright, so looking at some more practice problems about Elmer's survey, we're going to answer a few questions here and we're going to practice together. So it says, in how many households was the number of pets greater than the number of people? And we're going to put a small X over the households on the scatter plot. So we got to take a look at our scatter plot, and I've brought one over here to the right, and we're going to put an X at anywhere there are more pets than people. So in the first spot, I see there's one person in the house and 3 pets, so there are more pets than people, so that gets an X. The next time I've got 2 people in the house but no pets, so that doesn't work. I've got 3 people in the house and they've got 1 pet, 2 pets, that doesn't work. Then I've got 4 people in the house but they've got 6 pets, that's more than 4. Again, I got 4 people in the house and they've got 8 pets, that's way more. Then I've got 5 people in the house, they've got 3 and 4, that doesn't work. 6 people in the house with 4 pets, 7 people in the house with 4 pets, 8 people in the house with no pets, that's enough people I think, and then 9 people in one house with 1 pet. So none of those get an X, so how many households is that I put X's over? Looks like 3, so I'm going to write 3 households. Then it asks me to find what is the average or mean number of pets in these households. So what I'm going to have to do here to find average is I'm going to add up all of the pets and divide by the total number of households. So I'm going to add up all of my pets. So I've got 0 plus 0 plus 1 plus 1 plus 2 plus 3 plus 3 plus 4 plus 4 plus 4 plus 6 plus 8. That covers all of my pets. And when I add them up, I get 36. And then I'm going to divide by the number of households. And we know the number of households because we counted it when we figured out the basic information about this, and it was 12. So I'm going to divide 36 by 12. And when I do that, I'm going to end up with 3 households. So 3 households is the mean. Then I need to figure out the median number. So that's the number in the middle. In order for that to work, I have to write all of my numbers in order from 0 least to greatest. So I'm going to write all of my numbers in order. So I've got 0, 0, 1, 1, 2, 3, 3, 4, 4, 4, 6, and 8. So I've got them in order. And now to figure out the one in the middle, I'm going to start putting X's on both sides of my problem until I've got just one in the middle. So I'm going to take an X and I'm going to cover the 0. Then I'm going to take an X and I'm going to cover the 8. Take an X, cover the other 0. Take an X, cover the 6. And I'm going to keep going about this way until I've got just one number left in the middle. However, here I'm going to end up with 2 numbers in the middle because I have an even number of households. I have 12 households in this survey. So what am I going to do when I reach the middle and I've got 2 numbers? Well, usually I would add them up and divide by 2 and find the middle between those 2 numbers. But in this case, the middle number is the same. So if I add up 3 plus 3 and divide by 2, I'm still going to get 3. So the median number here is 3 households. The next question says that Elmer lives next to the Henderson's family, and they have 7 people in their home. How many pets do they have? So I'm going to just take a look at my graph and look over where it says 7 people, and luckily there's only 1 dot in the 7 people area, and they've got 4 pets. So the last question asks, why do you think there are no points on the y-axis? Well, if I'm looking at the y-axis, why would there be no points? Why would there be no people, but there might be points of pets? Well, there are no houses that have just pets and no people. So that will not work. You can't just have a house that has a whole bunch of pets in it and no people living there. And you say, yeah, you can. I was like, no, if you just have pets and no people, that's just a bunch of stray dogs. Pets have to actually be owned by people. All right, let's go ahead and take a look at the next one. And the next thing we're going to be doing is creating a scatter plot ourselves. So as Haley took a survey of the cafeteria, she asked the students about the number of minutes that students spend on the bus and the number of siblings they have. Create a scatter plot based on the information we provided. So the first thing that we talk about is the minutes of bus, and the next thing we talk about is the number of siblings, and she's put that in a nice little chart for us. We're going to take that chart, we're going to put it on a scatter plot. So the first thing we're going to need to do is label our sides. So we're going to label minutes on the bus across our x-axis because that's the first thing that we were given. And we're going to label the number of siblings on the y-axis because that was the second thing that we were given. Then we're going to write in numbers that make sense. So taking a look at my numbers of siblings, I've noticed that I've labeled my axis 0 through 4 because no sibling number is higher than 4 and I can count by ones. However, on the minutes by bus, I noticed that it goes from 0 to 19, so 0 means we probably have some walkers, and 19 means they probably live the farthest they can from the school. But if I count along the bottom of my lines, I notice I can't go by ones because then I won't be able to fit through 19 on there. So I'm going to have to go by 2s. So I'm going to label the bottom of my scatter plot by 2s, so 0 through 20. Then I'm going to just take my points and I'm going to put them on there where they match. So the first one, I've got 0 minutes on the bus, but they've got 2 siblings, so I'll go ahead and put a point right where it says 0, 2. The next thing, it says they spend 8 minutes on the bus and they've got 2 siblings, so I'm going to go over to 8 and bring my point up to 2. Then they've got 5 minutes on the bus, but they've got no siblings, so right between 4 and 6, there's going to be a spot across the x-axis. Then they got 12 minutes on the bus, but they've only got 1 sibling. Then they've got 19 minutes on the bus, and they've got 4 siblings, so I'm going to go all the way down between 18 and 20 where the 19 would be and bring it up to the 4 siblings. Then I've got 0 minutes on the bus, but they've got 1 sibling. And 3 minutes on the bus, and they've got 3 siblings. So there I've go ahead and made my scatter plot by putting all of my points where they belong based on the chart. Let's go ahead and take a look at the next thing. Now we're going to talk about correlation. Correlation describes the relationship between 2 variables. Correlation can be shown 3 different ways. It can either be positive, it can be negative, or it can be neutral. Sometimes scatter plots show a correlation between 2 variables. So a positive relationship, a negative relationship, or a neutral relationship. We're going to talk about what each of those look like now. So here we are with our 4 types of correlation. Wait, 4? I thought we just said there were 3 types of correlation. We're going to explain why there are 4 here when we just said there were only 3. So let's take a look at our upper left-hand corner first. So first we call this correlation positive. As time spent studying increases, students' grades increases. So this is a positive correlation. As one thing goes up, the other thing goes up. That's what makes it a positive correlation. It doesn't necessarily have to be a good thing. In this case it is, that the time studying is a good thing and the student's grade going up is a good thing, but that doesn't necessarily make that a positive encounter. The positive correlation is that both things are going up. Now let's take a look at the upper right-hand corner. This correlation is correlation we call negative. As time spent training increases, time on the 100-meter run decreases. So, as one thing goes up, the other thing goes down. This is what we call a negative correlation. Now, going faster in the 100-meter run is obviously a good thing, but just because it's a good thing doesn't make it a negative correlation or positive correlation. It does not matter what the situation is. That is not what makes correlation positive or negative. In this case, it is a negative correlation because as one thing goes up, something else comes down. So now let's take a look at the bottom left. This correlation is what we call correlation neutral. As the number of people increases, the cost of parking is unchanged. So in this particular situation, no matter how many people are parking, the cost of parking is relatively the same, which makes sense. If you go to a parking garage, they charge the same number of cars, charge you for the same number of cars, despite the number of people that ride in the car. Bottom right-hand corner, this correlation is not really a correlation. This is no correlation. And there is no relationship between shoe size and test score. So no correlation is not a type of correlation, but it is something that you will see where there is nothing, no up and down. As something happens up, something else goes down. That is no correlation. So we have no correlation as well. Let's go ahead and take a look at the next one. Okay, now we're going to talk about something called the line of best fit. So it says this scatter plot shows the price of menu items as G compared to the average number of times that item is ordered each night. So there are a couple questions that I want you to answer on your own first. So go ahead and pause the video now, answer those two questions on your own, then press play again to see if you are right. So how did you do? Did you count the number of items and get 14 by counting the X's? And in general, as the price of the entree increases, the number of times it is ordered decreases. Obviously, the more times something expensive it is, the less people are going to order it. So if a data shows a general trend, we can use a line to estimate the trend. This shows the relationship between the two data sets. So we can use a line to estimate the trend and show a relationship between these two data sets. So now you're going to use a straight edge to estimate the line of best fit. So we're going to draw a line that gets the most number of X's on it, some a little bit above, some a little bit between, and we call this the line of best fit. So I'm going to take my straight edge and I'm going to try and draw it so that I get the most number of X's along the line, or some a little bit above or some a little bit below. And this is my line of best fit. And I can use this line of best fit to make predictions and make estimates about the general trend. And let's see how this works in practice. Okay, I want you to try now practicing drawing a line of best fit using a straight edge. So use a line of best fit for your straight edge, and then you're going to answer which type of correlation you can see or estimate from the trend of that line. Go ahead and pause the video now, try those two problems for yourself, then press play again to see if you are right. How did you do? Were you able to draw the lines, getting most of the points on your line? And then were you able to use that line to determine the left-hand side we had a negative correlation, and on the right-hand side we had a positive correlation? Now let's talk about outliers. Okay, an outlier is a data point that does not follow the general trend. So it's something that if you look at your graph, you see X's or points and they're nowhere near where you would think the line of best fit would be, and we call those outliers. So taking a look at our two graphs here, the first thing we're going to do is circle each outlier. So I'm looking at Chez Henri, I see the line of best fit, and I see all of my points there. However, I've got 2 points over here that are kind of sticking out, and they are my outliers. Now we're talking about monthly gas usage, and this is if you were to use gas to heat your home, not gas for your car. If I'm looking, I've got 1x way out here, so I'm going to circle that, and that is my outlier. Now there's always an explanation for these outliers, like why they happen. So let's take a look at a possible explanation for Chez Henri. So although these dishes are really expensive, they're ordered quite often. Well, why could that be? One of the possibilities could be that it is a really well-known dish and that they are famous for it. So maybe it's a really nice steak that they cook very well and they're very well-known for it. Maybe that's something that people order a lot because it's what they're really well-known for. Shifting focus over to the gas graph, why would people not be using a lot of a lot of gas to heat their home when it's cold outside? And a possibility for this would be that they were on vacation and they were not home to use the gas that often. Maybe they have a house that they go to in Florida for the winter, and then therefore they don't use a lot of gas because they're not home and they don't need to keep it heated as much. All right, let's take a look at the next one. Okay, now we're going to make predictions based on our line of best fit. So it says the scatter plot shows the amount of gas used on different car trips. Use the line of best fit car trips to make predictions. So the first question asks us to predict how much gas you'll need to drive 220 miles. So if I'm going over the 220 mile range, how far they've driven, I'm going to bring my finger up from 220 over to where the line of best fit is, and that answer is going to be somewhere in this range of the graph. So around there is the 220 mark. So if I'm looking over to the left, I see that's going to be about 7 gallons of usage, as it's somewhere between the 6 and 8. So I'm going to say about 7 gallons. Now, is this going to be 100% accurate? No, we're making predictions. We're not stating facts. We're just predicting what might happen or what might be true. So the second question asks, predict how far you can go with 5 gallons. So again, I'm going to go over to where I might be looking at 5 gallons of gas, and I've got 5 gallons of gas right here, and I'm going to draw it over to my line of best fit to see about how many miles I could drive, and it hits right about the 150 mile mark, maybe a little bit more, so I'm going to say 150 miles. If you put 160, I wouldn't say that's wrong either, because again, we're just trying to get an approximation, a prediction. We're not going to be able to say with 100% certainty. Let's take a look at a few more predictions. So this says the scatter plot shows the height of people on Helen's swim team, and you use the line of best fit to make a prediction about this. So, predict the height of a 9-year-old on the swim team. So I'm going to go over to where the 9-year-olds are, and I'm going to draw a line up, and I'm going to see about where it hits, and it's just under the 4-foot mark, so I'm going to say 3 feet 11 inches. Okay, so if that's that for that one, and then it says predict the age of a swimmer who is 5'3". So I'm going to go over to where the height of 5'3" is, and when I look at that, I see that they are about 15 years old, because that's where about they hit on the graph. Again, these are predictions; they're not 100% fact. So the next thing says, is this scatter plot a good tool for predicting the height of a 22-year-old? Why or why not? And this graph would not be good for predicting the height of a 22-year-old because people stop growing at around that age. So while it seems that it's going up here and it has a positive correlation, as people are getting older, they're getting taller, that's true, but eventually people stop growing at around their 20s and they start to stay the height that they are, don't keep getting taller and taller and taller. So this graph would not be good for predicting that. Now let's try some practice on your own. Okay, here we have a few practice problems based on all the things that we've talked about so far. I want you to try them on your own, so go ahead and press pause, complete the problems by yourself, then press play again to see if you are right. How did you do? Were you able to answer all of the questions? The most important one says, if Josh wants to predict his mile time for age 25, should he use this graph? Why and why not? You should have said yes. As he gets older, his time will decrease, and at 25, he'll still be young enough for his time to decrease. Obviously, this graph can't work forever, because when you're 80 or 90 years old, your time is not going to continue to decrease. However, at 25, he's still young enough for his time to decrease. He is not yet too old. Let's take a look at the next set of practice problems. So here we have a scatter plot that shows 4th period test scores, and it also has a line of best fit. I want you to go ahead and try and answer the questions for yourself. When you're done, press play again, because the video will be paused now that you're going to do them. And then when you're done, we'll see if you are right. How'd you do? Were you able to get all the answers that I got? Did you get everything correct? If you did, go ahead and move on to the next one. If not, go ahead and check your work to see where you may have made a mistake. Here we are at our final set of practice problems, and we're talking about Nick tracking the number of days he went to hockey practice and the goals that he scored. So I want you to go ahead and try and answer these questions for yourself. Pause the video, then press play again to see if you've got all of the right answers. How did you do? Did you get all of the answers correct? If you did, great. If not, go ahead and check your work and see where you may have gone wrong. This brings us to the end of this video. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.